All right, we are continuing with Euclidean geometry. So we have to do some exercises. This is, we can say, exercises 2. So before we do these exercises, I want you to remember this. If this is our circle and this is a center, the previous grade we learned the angle. This is a center O. If we have this, we can call this is a O1. If we have a chord here, another chord, touch this point A, B, and then here we have a C. So we found that this angle O1 will be double the angle C. Okay? Will be double angle C. And also, if you have something like this is the center, and then we have this and this. So this angle will be, let's say here we have a O, O1 is here, and then we have a B, C. So the angle of O1, so the angle O1 will be equal to double C. Or if you have center, this is your center, or you have this line. So if we have a chord that goes like this, another chord goes and attach here. It's still this angle O1 is double, let's say A, B, C. So the angle O1 is still double of this angle. Alright. So if you know this theorem, you'll be able to solve this question. The next one you have to know, you know that if you have a chord, we have a center, or if we have a line from the center, bisect this chord A, B by a point C here. Bisect means these two sides are equal. So, which means this will be a radius and this is a radius, okay? So, meaning that these two angles, this will be 90 degrees and this will be 90 degrees. So, this will be a right angle triangle, okay? So, these two angles should be equal. Why? Because the radius are equal, okay? Now, if you know this, you'll be able to solve this question. Can we find now O1? Okay? Let's find O1. Question A. O1, O2. So O2 will be equal to what? Will be equal to double K. Angle at the center. This angle at the center is double of this angle. Look at, we have a OP, we have a ON. Can you see? Then we have from N to K and from P to K. So the bottom point for O join the two chords by K. So meaning that this is an angle at the center is a double angle at the circumference. So therefore O2 will be equal to 2 times 32. So will be 64 degrees. What is the reason? Angle at the center of circumference. Okay, now here we know it's already 62. Let me use the green color. Alright, so we can, it's better when you're doing geometry, you must put different color so you can know what you did or what you add. Okay, so now we go to 64 there. Alright, now next question is, as we found B, we have to find point B, meaning that we have to find point B. We are going to look for O1. Okay, now remember they gave us 26 here. How to find the O1? So if you can see, this is a straight line. Okay, so O1 plus O2 plus O3 is the angle of a straight line, so the total should give us 180 degrees because it's a straight line. So O1 plus O2, so we plus O3, so we know already what? O2. So if we know O2, what are we going to do here? We know O2. It's easy to know what? O3. Why? Because remember, M, there we go, M2 is equal to 90 degrees. Why? Because line from the center, okay, from center of a circle, it's a perpendicular to a chord. It's perpendicular to the chord. Okay, so now once we have a 90 degrees, so here we have a 26 degrees, so O3 will be equal to, because the sum of the angle in a triangle, the sum of angle in a triangle is equal to what? 180. Okay, if we have a 180, as we have a 180, and for the rectangle, I mean the triangle, so we know that M2 plus N26 plus O3 should give us what? 180. So to get O3, we need 180 minus what? 90 degrees minus 26. So that will give us what? Will give us 64. So we say O3 is equal to 64. So you can just write straight and do not write this, okay? And the reason you'll give will be what? Angle of what? Straight line. Okay. Now, as we know O3, we know O3, we know O2, so O1 will be 180 minus 64 minus 64, so will be 180 minus 64 plus minus another 64, so here will give us 52 degrees. The reason why, it's also, oh sorry, this is not the angle of a straight line. Oh, okay, sorry. So this will be sum of the angle in a triangle. Okay, and then this one now, O1 is 52. Why? Because angle, we can just use the sign of an angle. Angle of what? Straight line. Finish. Okay, so simple. Now let's move to the next question here. Let's call this is 1 and this is question 2. So what will be question 2 now? Question 2, they say prove giving reasons Kn bisect the angle OKP, meaning that these two sides should be equal. This angle and this angle should be equal. If this is 32, this should be 32 degrees. Now, I want you to look at one thing here. O1 plus O2 will be equal to what? O1 plus O2, if you look at, will be equal to 116. Alright? 100 and what? 16, okay? 16 degrees. So, if we know these two angles, now, as this OK is a radius, ON is a radius, meaning these two sides are equal. So this is an isosceles triangle, meaning that the angle of N, the angle ONK and the angle OKN should be equal. Alright? So meaning that the K2 will be the angle that will be K plus K2 plus this divided by 2. Okay? So we will say that the remaining angle here, if we have this, so K2 alright, plus ONK should be equal to 180 minus 116, because the total of the angle here, these two angles give us 116, okay? So the remaining here will be what? 180 minus this angle, that will give us the sum of this angle. So this gives us what? 180 minus 116, this will give us what? 64. This gives us, okay, 64. Therefore, if you divide by 2, because the two angles are equal, we find that K2 is equal to 32 degrees. Why? Because we found that we do this. We find that K2 is equal to what? 32 degrees. Because we divide 62 by 2. What is the reason? Angle of radius, same radius. The reason, you can say just radius, or you take this off, okay? So therefore, if you bisect means that they are equal, okay? So therefore we found that K1 is equal to what? K2. So it's proven. So we come to the conclusion, we'll say K N bisect OKP, because to prove that they are Kn bisect OKP, it means that you have to prove that K1 is equal to K2. This is what we prove. So thank you. Try to do more exercises for yourself, and if you have a question you can ask. Thank you.